So here we go. Here's our guided practice for specific heat. Now, again, we're going to do one question at a time because I can't have videos be too long in order to upload them to my YouTube channel. All right, so the first thing we're going to do is we're going to read our problem. We're going to underline all the important information and we're going to label it. And then we're going to put a box around our question. We're going to label just like we do in gas laws. So here we go. How much heat is what I'm looking for, is required. Heat, if you remember, is our Q value based off of our notes that we had over here, right? Q is heat. It is required to raise the temperature of a sample of copper from 10 degrees Celsius to 55 degrees Celsius if its specific heat, that is my C, specific heat is C, and its mass is 10 grams, is my M. Let me go back up and I need to label my temperatures. 10 degrees Celsius, it says from 10 degrees Celsius, so that's where it's starting. So this is my initial temperature, TI, to 55, that is my TF. All right, so we have everything labeled. First thing I want to do is, just like in gas laws, we cannot keep our temperature in Celsius. We must change it into Kelvin. So in order to change it into Kelvin, if you remember, we need to go ahead and add 273 to these numbers. So TI is going to equal 10.0 plus 273. That is going to equal not 283, right? I'm going to cross this out. This is going to come 283. My TF is equal to 55.0 plus 273, and we get 328. So I'm going to change this one to 328. All right. So let's write out our equation. Our equation is equal to Q equals MC delta T. Now, we need to go ahead and we need to calculate this delta T term first so that we don't forget it and that we have it. I'm going to do just that. So our delta T, our change in temperature, is equal to T final, so TF minus TI, the final temperature minus the initial temperature. So I'm going to plug in our numbers. The final temperature was 328 minus my initial temperature, which is 283. So the delta T, or the change in temperature, is going to be equal to 45 degrees Celsius. Not Celsius. It's just 45 because it's a change in temperature, right? Just 45. That's my bad, guys. All right, so now that we have our delta T and we have all of our other variables, we can go ahead and we can plug in what we need. So in place of Q, I have my Q up here. That is my question. That's what they're looking for me to find. So I'm going to put X is equal to the mass, which is 10. And all these are next to each other. So in math, when our numbers or letters are next to each other, that means multiplication. So I'm going to put parentheses around this. My C, I labeled my specific heat. And then the delta T, which is 45. All right. So now I just need to solve this problem. X is by itself already, so I do not need to isolate X. All I need to do is plug all this into the calculator and get my answer. So I'll do 10 times 0.384 times 45, and you get X equals 172.8. I need to put my units, right? And it's Q, so Q can either be joules or it can be calories. In order to know which one it is, you look at the specific heat, and if you notice, There's the J there for joules. So that means this must be joules. And we're done.